button, and yeah, go for it.
All right, let's make this a little bit less large. Can everyone see my screen okay? Okay. All right, so today we're going to talk about some work that I've been doing around adding some rudimentary anomaly detection. So we had a little, so if you'll remember last time, Nick showed off some of the work that we did with the profiler and how it can be used with the statistical sketches to scalably answer statistical questions about your data. And the next obvious thing here is to start doing some statistical outlier detection. So outlier detection has a long and storied history. I won't get into too much of it, but there are a couple of different approaches. One of the main ones that people use is statistical based, and because we have the statistical tooling inside of Metron, that becomes more and more viable. Okay, so what I've done is I've created a couple of functions to support some rudimentary, one particular algorithm. It's called median absolute deviation. So median absolute deviation is provides what's called a robust estimator on variance, right? So if your data is normally distributed, which not all data is normally distributed, so we're talking about numeric data here. So think streams of things like, number of bytes in, bytes out, length of URLs, stuff like that. Right? If you want to figure out when your system when your system sees something that is abnormal in a numeric stream of data, that's where anomaly detection can come in particular, it's the statistical anomaly detection. So median absolute deviation is a little bit better than the normal, what a lot of people think of, which is, okay, I have my mean, how many standard deviations away from the mean is this value, and if it's more than k standard deviations away, then I'm going to say that it's an anomaly, right? That's a very simple way to do it. And we could do that, we can still do that with the system as it is now. The problem with that is because you're getting a sample of the data, you're only looking back a window, you're getting, the standard deviation is going to be off. It's not going to be a robust estimator because you're getting population variance. You're getting sample variance as opposed to population variance. And the other thing is standard deviation really doesn't mean a lot for non-normally distributed data. So a lot of researchers, a lot of people prefer doing things using a technique called median absolute deviation. So the idea behind median absolute deviation is instead of capturing just the statistical summary of the values coming in, you're also capturing the statistical distribution of how far away each value is from the median of the previous window, right? So Metron allows you to do this now. I've created some stellar functions that allow this. So we'll see how to hook them in. Hopefully it will become obvious. So I've created a stream of data into a Kafka topic called MAD, or median absolute deviation. And so I'm randomly generating a stream of data. So this is going to be normally distributed, so Gaussian noise, centered around 0 with a standard deviation of 1. So really close to the center, but can expand out, right? And I'm pushing them into my Kafka topic. And so I'm using the CSV parser because it's just a number. I'm capturing that value in the value string, and I'm transforming it to a double. All right, easy peasy. And in my enrichment, I'm doing a stellar transformation and calculating the score. So there's a couple of functions here. So the idea is this data is passing through into the profiler, and the profiler is capturing the sufficient statistical state inside of HBase, inside the profiler, that I can grab as the data is flowing by. So I want to look at and because it's using the same kind of statistical functions that we used before, the state is mergeable, just like the basic statistical state is mergeable. So I want to grab from the profiler, from a profile called sketchy_mad, because it's using sketching algorithms. I call it, that's what I'm calling the profile. I'm capturing a global state, so it's not on a per entity. The entity is, there's just one entity for the whole system. And I want to grab a 10-minute window back. And I'm going to take this, so I'm going to get, I've configured the profiler to capture state every 1 minute. So I should get around 10 of those back. And I want to merge that state together so that I have a 10-minute window perspective. And I want to use that to score the value coming in. Right? So the first argument is that median absolute deviation state, and the second argument is the value. Okay, so the way this is going, what median absolute deviation score is going to give you is it's going to be a modified z-score, and it should vaguely associate with for normally distributed data. It should roughly associate with your notion of a standard deviation. So if you can imagine, except it should be more accurate with less data seen. So because I'm capturing at the 1 minute interval, it's going to be extremely sketchy. But if I captured maybe an hour back or 5 minutes back even, it would be a lot better. So I'm going to say if I'm more than 3.5 standard deviations away, because my data is normally distributed, then I'm considering an outlier. The other thing to point out is that median absolute deviation, unlike just plain standard deviation, has an interpretation for non-normally distributed data. And for security data, that's almost everything you're going to see. You're not going to see that much Gaussian noise, I suspect. So if you're doing counts or if you're doing lengths of URLs and stuff like that, that's going to have a long tail. Okay, and I'm going to consider an outlier if it's more than 3.5. If it's more than 3.5, if the z-score is more than 3.5. Now let's look at the profiler. All right, so I added something to the profiler to allow this to happen. So I'm calling my profile sketchy_mad. There's only one entity called global, and I'm going to do it for every data point, right? Because that's how it's set up right now for this particular streaming data. So I have an initialization routine where I'm grabbing back a 5-minute window and initializing the state. So I'm actually calling the profiler output from within the profiler, right? So I'm looking at a 5-minute window back and initializing the state. Now there's an extra state here. There's an extra callback hook here that I've added called tick update. So this is called after the tick is finished, and it's to initialize the state of the next tick. Okay. So I'm going to do essentially the same thing I did up here, except I'm going to take a 5-minute window back plus the current state. So that should give me a rolling 5-minute window as the data flows through. And for every method, for every data point, for every message, I'm going to add that message to the state. And then at the end of the day, I'm going to capture the state for every tick. Okay? So going back here to my Stellar shell, I'm going to grab the state. All right, I'm going to grab a 10-minute window. All right, so this output is just because it's debugging for me, but you wouldn't see that if you were to run it off of my pull request. And I'll score. All right, so let's look at the score for 3.0. So it's around 3, which is what I would expect, because 3 is around 2 standard deviations away from the mean. This is normally distributed data, but I'm only getting 1-minute windows, so the granularity is kind of coarse. So let's look at 4, and you can see as I get farther and farther away from the median, which should be 0, I'm getting farther and farther away. My z-score is increasing. So you can imagine the z-score has a couple of uses. One is a cutoff for what's considered an outlier, but the other thing is if you want to rank things in terms of weirdness, you can. It's a nice ranking function. Okay, so I'm going to send some data through that I consider weird, and I want to make sure I can see it in Elasticsearch. So I'm going to put 4 in there, so some synthetic data, and I'm going to share with you Outlook. Let's see here. Let's see. Okay, should be able to see Elasticsearch here. And I'm going to take a look at my browser. I'm going to refresh. Just look at MED. We have a lot of data here. You can see this is very varied. So I'm going to go here and kind of zoom in to the one that hopefully is an outlier. So that means it is alert. Should be set to true. And I see 1 here, and you see the value is 4. The triage level is 10, which is what I set, and the outlier score is around almost 4. So you see, this is it's a mostly working version of median absolute deviation. How it differs from a more traditional implementation is this is a implementation that works on a sliding window, and it's using statistical sketches instead of computing the entire composable statistical sketches instead of calculating a precise median. So at that point, I'll stop and answer any questions that anyone has. So this is just the beginning of a couple of other outlier analysis projects and analytics projects. You'll see more of this kind of stuff. Some techniques work well within this kind of setup. We're tending to prefer states that are composable, like the statistical states, but not everything fits within that. So there's more coming, but this is the kind of a first cut, kicking the tires.
Hi, so Casey, can you explain why we chose to do like probabilistic structures?
Yeah.
Yeah, go ahead.
Yeah, so the reason why we chose to do statistical structures and probabilistic structures is because, one, there's a lot of use in terms of modeling analytics that way, right? In terms of modeling what's a shock to see in a system, right? It makes a lot of sense to go to statistics for that. The other thing is the structures themselves turn out, at least in the single variable case, to be extremely streamable. So a lot of you have things like robust sketching algorithms. You can merge things together. It fits a lot of the requirements that you see around streaming analytics, which is different than batch analytics. So it fits well within the system. So that's kind of the short answer. And median absolute deviation, in particular, is a nice one because it's well accepted. It's been around forever. Actually, I think Gauss was the one who initially suggested it. So it's been around at least since the 17th century. It's well known and one of the more popular ones.
And so can you also explain the types of anomalies this would detect, right? So this is not appropriate for like a frequency domain type anomaly, right? This is primarily spikes over a threshold type of anomaly.
Yeah, so this is a situation, so this would detect, what you really want to detect in this is, yeah, like you said, spikes over a threshold. It should be fairly resilient to other outliers, so it should because of that rolling window and because it's using the median, it should be relatively smooth. But yeah, so the things like that you would look at is, well, there's been a lot of discussion around what users who may be pushing in URLs that are very long, right? A good use of that. A good use of this would be detecting situations where there's a spike in the in a URL size, right? That would be a good use for that. So yeah. And situations where it wouldn't necessarily be a good idea to use is situations that are extremely volatile, I guess, I would say, as well. You're going to get a lot of false positives. The trick to this is really figuring out your thresholds also. So there's a principled way to do that and a more empirical way to do that. I've had the most success in doing the empirical way because the distribution often changes and you don't know the distribution of the data coming in. So kind of figuring out, what the threshold is a good, by trial and error, is a good exercise.
And the fact that it's a robust estimator is actually a really good thing because, as you know, network patterns change, right, from day to nighttime, right? So the definition of what a threshold is,
right,
is dynamically adjusted. So that's one of the reasons why we built it.
And you need to see far less data in order to get a more accurate picture of the real variance, which is what it's estimating. It's a lot less susceptible to flux as opposed to standard if you're using standard deviation.
All right, so I think that concludes this week's demo. You guys, any questions or comments? All right.
To ask one question about the thresholds. Whether you think it would be appropriate to take a longer dated profile or a longer period profile median as a threshold over that to essentially get a smoother distribution as the basis for the threshold. Do you think that would likely work?
Absolutely. So you should, in fact. So the levers that you have at your control is how often the profiler takes a snapshot. The snapshots should be roughly the same size memory-wise. So you can look back as far as you want, and they merge together just fine. So taking a 10-day snapshot, it all depends. The length of the window back all depends on how seasonal your data is, really. So if your data is super seasonal, then you want to target the look back window appropriately. But yes, the longer having a minute tick means that I get. And having the frequency of spitting out the data like I have here only gives me 60 samples to figure out the distribution, which is very small, which is why you saw the median absolute deviation be off by 0.5 or so, which is not ideal. Right? If I had a longer window there, it would have one be more accurate and two be a lot more smooth. Any other questions? This is a good one.
All right, guys. Well, thanks for your time, and we'll see you back here in 2 weeks for another demo.